This next section of the presentation has a lot of graphs and charts in it, and they're all taken from the IPCC's AR5. The first one I want to explain and get into is the observed globally averaged land and surface temperature anomaly from 1850 to 2012. Notice on the y-axis we have temperature anomaly in degrees Celsius relative to the 1961 to 1990 average. Notice that the center of the y-axis is 0. This does not mean 0 degrees Celsius. Instead, this is the average and a baseline, thus, for the 1961 to 1990 land and ocean temperatures. So from this average, then we can ask, is the temperature warmer or is it cooler relative to this average? And on the x-axis, we have 1850 to 2000 plus. So when we look at the time span here, we can say that from 1850 to 1900, 1900 to 1950, Earth's globally averaged land and ocean surface temperatures were relatively cooler than the 1961 to 1990 average. And then in the 50 years of 1950 to 2000, they started to become first about the same as the 1961 to 1990 average, and then started to climb. And notice that climb really starts around, say, 1960-ish, 1970-ish, 1980-ish, somewhere in that area. The latter half of the 20th century, you see a remarkable change in terms of the slope of the line, where you have a steep incline. And thus we can say the latter half of the 20th century, particularly the latter half of the latter quarter of the 20th century, was when Earth's land and surface temperatures started to increase relative to the 1961 to 1990 average. Notice also that within this chart there's a lot of different lines. Some are orange and then blue and then black. The reason for this is that lots of different studies and lots of different data go into creating a chart like this. In order to simplify things, it might be better for the IPCC to simply draw one line, but that would be not as accurate as representing the variety of data that they've got that goes into this chart. Unfortunately, that makes the chart a little bit more complicated, but it also is a more accurate representation of the data. So we've got data that's represented in black, and then in orange, and then in blue. They're slightly different, but they all show the same basic trend, that in the previous century, temperatures were generally cooler than the 1961 to 1990 average. And then in the latter quarter of the 20th century and now into the 21st century, temperatures are relatively warmer than the 1961 to 1990 average and climbing fast. This next graph, or graphic, shows you the observed change in surface temperature around the planet from 1901 to 2012. Beneath the map, beneath the projection, you've got a bar showing you temperature in degrees Celsius. And the light blues show temperatures that are relatively cooler from negative 0.2 to negative 0.4, etc. And then you've got temperatures that are in the orange, reds, and purples that are relatively warmer. And we have then 0.2, 0.4 all the way up. As we look in the projection, we see that land surfaces, both in North and South America, as well as in Asia and in parts of Africa, have significantly warmer temperatures than other places. And we have that being illustrated with this purple color. So you could say that portions of Canada around, say, the central part of the continent, portions of Brazil around the Cerrado, portions of Asia around, say, central China and Kazakhstan, and then around near Morocco with North Africa, those places have an observed change in temperature of 1.75 to 2.5 degrees Celsius. They are essentially warmer than would be expected. We also have some cooler areas, particularly off the coast of Greenland, in and around the Iceland area. Here we have temperatures that are cooler relative to the rest of the planet.